Today I'm going to talk about a couple things. First of all, neuroplasticity and how the brain can change. That's been the theme that we've been developing, and exactly how meditation makes that happen. And then we're going to, that was cleaning up last time's lecture, and then we're going to move into the distributed networks of the brain and exactly how the brain is functioning during meditation. So first, let's clean up the plasticity. This is posted. Yeah, it's the same place it's always been. It's just the new file. So this is just a cartoon. This is nothing quantitative, but it'll help you understand what happens. And these are little zoom-ins of brain tissue at different points in a person's life. And so here, the newborn, these are neurons, and as the person ages, the neuronal density goes up, and you sort of reach this peak of neuronal density at around 2 years. You guys, since the age of 2, you've been on the downward slope. No, it's not quite the right way to think of it. But we start pruning back the neurons, that neuronal density, by saying these neurons are useful and meaningful, and these neuronal pathways are not so useful. All right, and so you can think of it as a way of making the brain more efficient. Actually, the 2-year-old brain is not especially efficient, but everything's in play at that point. Everything's sort of plastic, and whatever that brain, whatever direction it needs to go in, it has a wider landscape of possibilities in front of it. Right? Yeah.
How much you're distracted?
Yeah. So there's a I could go into the development of the brain during that age, from like pre-adolescence to adolescence, and essentially the bottom line of all that is the last part of the brain to develop is the prefrontal cortex, also called the neocortex. It's sort of the like evolutionarily newest part of the brain. It's what took us from animals that didn't have this massive thing up here that humans have, and then grew these big foreheads with all that brain. That is the inhibition portions of the brain, the control portions of the brain, the parts of the brain that are discriminating in terms of saying what I want to do, what I don't want to do, that sort of thing. And those really begin to anneal and develop during adolescence. So the mental pattern, even into where you guys are now. So this is a crucial time in, you're leaving that window, but you're still in it. A crucial time in neural development right now, where that frontal cortex in you is developing. And so the like mental habits that you develop, they are ones that are more likely to stay with you for life. And so it's important to be aware of that during your adolescence, during your teenage years, because that's the real time when all of that develops. The last of the neural cortex really starts taking on the character that it'll have. So I showed you this, and I was meant to update this slide again, where this is showing where white matter is actually going up, but gray matter is going down. And I said this is meant to be neuronal density or pruning, and so this is, you can think of it as the brain becoming more efficient, doing a better job with less, and this is going up, and I said this was connectivity, right? So the brain is becoming increasingly connected as you get older, although it begins to plateau. Here is just one of many studies that are out there showing the connectivity. So they're using this diffusion tensor imaging that I showed you, those really gorgeous color ones with all those threads that represented the white matter in the brain. So this is that kind of a study where it's looking at connectivity, white fiber connectivity between parts of the brain, the posterior cingulate and the dorsolateral prefrontal cortex, before and after mindfulness meditation training, relative to relaxation training. So we see that there is a significant increase compared to control in connectivity between these parts of the brain that have been identified as being involved in some sort of meditative practice. So somehow integrating the disparate regions of the brain that are involved in meditation. So let's see what effect that has on other aspects. So we talked a little bit previously about the endocrine system. Here's another just glancing blow at that. Interleukin-6 is a pro-inflammatory, what's called cytokine. It's a kind of a hormone that's associated with all these different problems. So increased IL-6 in the brain is associated with schizophrenia, depression, asthma, rheumatoid arthritis, cancer. There's a whole host of things that IL-6 has been correlated with. And it turns out that in these people who had this mindfulness meditation training, so they took a group of people, had them do this 10-minute meditation activity, listen to some DVD or CD or something like that, and meditate for an extended period of time. And people who did this had a lower IL-6 after over the 4-month previous baseline. All right, and the model that they have for this, they showed that in control there is connectivity. There's a correlation between activity in the posterior cingulate, which is this part of the brain that we pointed to last time, and IL-6 production. However, connection between these two brain regions that they showed led to an alternative path to lowering IL-6. So the IL-6 production is being controlled both by the cingulate and indirectly by the cingulate through the prefrontal cortex. So not only is there increased connectivity, but they're showing that this connectivity leads to a reduction in pro-inflammatory cytokines that are associated with a host of, when elevated, are associated with a host of pathologies, and some of them being neuropsychologic. You guys following me here? All right. So that was meant to be the end of last lecture. I didn't quite get there. But so now we're going to move. I'm still working our way through this list that I had from long ago. And the next one here is reduced activity in the me centers of the brain. Now, there is a slide that I put at the back of the slideshow that I should have put right in here, and I meant to put it here, but basically, I wanted to point out something, that the effects on the brain. So initially, in the beginning of the semester, what did I talk about when I talked about Louis Sullivan? Remember Louis Sullivan, the architect? He built the first skyscraper. Form follows function, right? So structure function paradigm. And structure function paradigm in this class means structure is anatomy, function is physiology, or how the body responds. And within this slide here, you can think of this top part as being form. This is the structure, the structural correlates of meditation. So we've been going over the ways that the body actually physically changes. All right, we have increased connectivity, we have changes in gray matter volume, et cetera, et cetera. And then the psychological impacts, that's functioning, right? How your brain is actually working. So we've been working our way through the structural changes, and they have functional correlates, right? All right, so let's see what I mean by the reduced activity in the me centers of the brain. So here's this article. A wandering mind is an unhappy mind. So this came out in Science, not quite 10 years ago, by a group at Harvard. And it's a pretty interesting study. They were looking at mind wandering. And what do they call mind wandering? They call mind wandering stimulus-independent thought. So when you are meditating, sometimes when you're meditating and I'm talking about, flowers and waterfalls or whatever I'm talking about, or, a glowing light in your toes, all the things I've talked about all semester, sometimes your mind is like, oh my God, that Japanese paper that I got to write. It's like, gonna kill me. That's mind wandering. It's like roving around away from the task that you may have an intention for. It's not a bad thing. Wandering mind is not a bad thing. It allows people to learn, reason, plan, create things. Being creative often involves letting your mind wander, right? It's one of the joys of life. And they posit that it is the brain's default mode of operation. The default mode of operation. However, it may have an emotional cost. So having a wandering mind, this default mode that the brain is in, can have an emotional cost. And that's what this paper is trying to look at. So we'll see that in a moment. They say here, mind wandering is about 50% of our waking life in an average person. About 50% of the time, half of the minutes from eyes open to eyes closed, morning to night, the mind is not on a task. It's wandering about someplace. And they say that this is associated with lower levels of happiness. Well, how do they show that? Why, you're laughing at that? Does that happen? Is that true for you? No? Yeah. Okay, well. Keep your attention focused here because we're going to learn about it. So, this shouldn't be like radically new information here that a lot of philosophies and religious traditions teach that happiness is found by living in the moment. And that a wandering mind, an unfocused mind, is actually an unhappy mind. Does anybody know this guy, Ram Dass? This book, Be Here Now? It's an old hippie book from the 60s. It was this whole thing. He was just like, be here now. He's actually apparently a lovely person. Sarah has met him a number of times. Didn't get her to talk about it. But let's say, are they right? Who thinks this is correct or who thinks it's not? Okay, so defend yourself, please, or at least the thought.
Living in the moment. It's not like you're focused.
Mm-hmm.
So like that's where your sole attention wander. Like you're either thinking about like something in the past that like really bothers you. Like you'd be like getting ready to sleep in the middle of the night and you just think about something that you said 20 years ago. You're just like, wow, I was dumb. Or like you'll be thinking about something in the future and like you at least because of fading what like is going to happen and like what you're going to do.
Mm-hmm. Okay. What about, is anyone going to take the opposite side of that? What do you think? Okay, let's hear what you think.
I think that the only time that your mind like really wanders is it's not fully doing. Like it's like trying to be like better and more success. Anyway, like when that would like bring
Uh-huh. So what's the difference here between there's a distinction that I think both of them are dancing around, but we can put our finger on here. Does anyone want to add to either of these positions?
I feel like it's kind of like in the middle. Like honestly, it always just depends on like how you feel. Like like at a moment, because I feel like sometimes when I wander, it is because like I'm unhappy with something, but sometimes I wander just because thinking about something random, like just looking at the snow. I'm like, really, like it looks like it's going like slow, but like there's some that are going fast, so it's kind of like, but like I don't, I don't know. It just it's weird. And then it's like yesterday I thought it was raining, and but it like I thought it was fog, but then I go out and it's like little like snow, and I was like, oh, that's cool.
Mm-hmm. Magical weather thoughts. Yeah. Yeah.
I think for me, like seeing those statements entirety,
You would disagree with it.
happiness. I think like happiness is like a combination of just live in the moment. But I
Yeah.
think like the outlook, like if your mind wanders, you have a positive specific example. Like if your mind's wandering, you're like productive. In that case,
Major overstatement.
Uh-huh. What do you think?
I think this is more like of a like, for people who like live in general. A wandering mind is not necessarily that like whereas like and like a wandering mind is the
So.
Was there something over here too with her hand?
Oh, yeah, but you can go.
You're
Okay,
next,
are you
though.
sure? Yeah.
Go ahead,
So,
just-
in my health psychology class, we talked about we might have even the literature says that mind wandering. So let's say you're thinking about something that more happens.
Yeah.
That over time still correlates less. I mean, I understand what you're saying. Like it almost just seems weird just to state it like, yeah, like something thinking about something else that is in that 1 second, but then I'm not. That's I'm unhappy.
Mm-hmm.
So I feel like because I mean, everyone's gonna. So I feel like I feel like the intention of being present, right? That because like so
Yeah. Okay. Yeah. Well, I'm glad that you're presaging the next slide, which will be the data. But yeah. Felicia, what?
Oh yeah, I was just gonna say, like it's a balance. Yeah, word like you have to define, even though like a general idea, like me going outside being happiness, it's like somebody else won't be happy. So like Jensen said something that like wander about the past or stressing, you're anxious, it creates these emotions that won't make you happy, I guess. So like in a way it kind of is living in the moment. You don't actually realize. Like I don't know if you guys have ever like in a really fun time and you're like you're laughing and then everybody's like in this like moment where they're laughing and then you realize that everybody's so happy and that feeling is like it brings you warm. I don't know. I don't know if you guys have experienced it. It's like a
Sure.
really great feeling. Yeah. So yeah.
You guys should try.
I already
Any more sharing?
I think it's like tough, like to live fully in the present, but at least you're like realistic. Like you've got to think about things that in the future, and you've got to like think about things you've done in the past to compare what you've done in the past to make your future better. So you can't only be thinking about like what's happening to you. 'Cause
Well, and there's a lot of pressure, I think, too. I've certainly, when I was a teenager, I think I might have been a person that lived almost pathologically in the moment. And I definitely remember having a lot of think about your potential that is being wasted. Here I am. I'm happy. Okay. All right. So here's the data that. Well, here's the study she's talking about. I'll show you the data in a moment. This was the study design. They had some sort of smartphone app, of course, that sampled somebody's ongoing thoughts. There was a little plug that went into the back of their neck and down.
Whoa. That's cool, but kind of
They
crazy.
just
little port. No, but you were able to record your feelings and the actions that you were doing during that moment. Which there's some things on here which are kind of funny. You'll see. Just imagining somebody fumbling with their smartphone in the middle of some of these activities. These were what they found. That number one, people are thinking about what is not happening at that moment about half of the time. They're not thinking about what's going on half of the time. They're thinking about past, what might happen in the future, or what will never happen at all. So all kinds of that leaves a lot of room there. So yeah. And then other thing they found was that doing this makes them unhappy. All right, so let's look at some of the data. 2,200 adults, a lot of people actually. It's a pretty big study. Almost 60% male, about 75% living in the U.S., otherwise, but not all American. And the mean age was 34 years of age. So these were the questions that they had. How are you feeling right now? Very bad, 0 to 100. Very good.
Oh wow.
How are you feeling
That's a
right now? How are you feeling? Rate it. Just like think that number.
69.
I'm at 86.
420.
I'm with you. 420. All right.
That's over 100.
I know. I know.
Yeah, they should have done a 1,000-point scale. That one. What are you doing right now? Okay, so they listed like a whole host of activities that they could be doing. 22 of them. Are you thinking about something other than what you're doing? And so your choices were no, that means you're in the moment. Yes, I'm thinking about something pleasant. Yes, I'm thinking about something neither pleasant nor bad. Just whatever. Right. Yes, something unpleasant. Something unpleasant. And so here is the data. If we look at this, this is the average happiness score, all right? And here were the responses relative to that average happiness score. So, so people actually are not especially happy when they're resting or working at their home computer or commuting to work. They're on average a little bit less happy. And then listening to the radio, whatever that is. Grooming, self-care. Doing housework. These are all things that are about average or less than average. And then there's some other things that are watching television, reading, relaxing, nothing special, shopping, praying, taking a walk, exercising. Making love. Making love.
What are you doing? Like, oh, I'm putting my data.
Yeah, that's the thing that was cracking me up. Somebody like on their smartphone trying to use the app. Their partner's like, really? Really?
Don't worry about
Live
it.
in the moment.
Do you have to do this now? Okay.
I feel like you're
Hey,
so-
what are you doing right now?
And so here were the responses for what to the this question, this third one. Are you thinking about something other than you're currently doing? So if they said yes, their mind was a little bit happier than average. All right, but if they were thinking, if their mind was wandering, they were no happier than if they were in the present moment, thinking about something pleasant. But that's only about a third of the time that their mind is wandering. The other 2/3 of the time that their mind is wandering, they're less happy than average. All right, either unpleasant or neutral mind wandering. So when your mind is wandering, you tend to be less happy. All right, and this is going to correlate with like work, things you don't. Yeah.
That seems
So
like too
all
high.
of these together is this mean. Right. So this
So
mean.
the activities above are even. No, that's just like
this.
percent of time.
This is the data as it correlates to this question.
Oh, like how
Right.
much time they.
And this axis down here is the response to this question. All right. And these are the response to this question. Does that make sense?
Yeah.
Yeah, it took me a minute to like understand what I was looking at too. But all right, so I guess I just went through this, but people's minds wandered frequently, regardless of what they were doing. They were in the moment there, I guess. So people's activities had a modest impact on whether their minds wandered or not. It actually wasn't super correlated with whether they were doing something fun, like working, or something horrible, like exercising. Almost no impact on the pleasantness of the topics to which their minds wandered. Okay, so on whole, people were less happy when their minds wandered during all activities. So I guess I already interpreted this. I don't really need this slide here. But the point, again, to reiterate, simply that if your mind is wandering to pleasant things, you're not more likely to be happy than if your mind was on the topic. And then if you were neutral or unpleasant, you are less happy in general. All right. So now we're going to jump to this idea of functional connectivity. Functional connectivity. I'm going to give you this little bit of understanding here, and then we're going to try to push forward what we're talking about when we talk about mind wandering. So when two regions of the brain are firing together, and I sort of started unpacking this idea last time when we talked about stabilizing synapses. When two parts of the brain are firing together, we call that functional connectivity. So what we're looking at here is percent change in activity in a brain region. And this is the yellow trace back here, and here's the orange trace. So these two disparate, geographically distant or separated regions of the brain are working together. They're doing something together. So whatever is happening when they're high activity here, that thought process involves both of those. And when they're at a low, they're not being used. All right. So this is functional connectivity. All right. And that's going to set the groundwork for us to talk about this default mode network. So mind wandering correlates with neural activity in a network, in a distributed network of brain areas called the default mode network. And the job of the default mode network is self-referential thought or self-referential processing. So self-referential thought, thinking about the self, thinking about internally generated ideas, mind wandering. And what are these regions? So we have the prefrontal cortex, particularly the medial prefrontal cortex. We have the dorsal cingulate cortex. All right, I've shown you the cingulate before. Maybe I should have put a picture up with a better diagram. But it's this region back here. This is the midline of the brain. This is the lateral side, so medial and lateral. This region here in the medial, along the midline of the brain, posterior cingulate, the prefrontal cortex area, and then this lateral parietal cortex is also associated. And a little bit of this temporal lobe down here. So it's the default mode network. There's a picture of it. We're going to talk about it now. What does it mean? So default mode network. It's the neural basis. It fires when you're having thoughts of the self. So autobiographical information, self-reference. So thinking about my hair is long and blonde. I want to be a stand-up comedian, but it's not happening for me. Things like that, right? When you're thinking about the self and describing yourself. And then emotions of yourself. So reflecting on yourself as a pessimist or an optimist or what have you, or I'm happy right now, or how do I feel, thinking about how I feel. So that is part of the default mode network. These are the brain regions that get fired up for this sort of thing. And you can see on the little brain histograms there the specific regions that fire during that, taken from a paper that I'll show you in a bit. So here are some other functions of the default mode network. These are all part of like the theory of mind or thinking about others. Your ability for me, I'm sitting here talking to you. What do I think is going through your head? Trying to think about what is in your head. That's part of my default mode network. All right. Being empathetic, so trying to understand the emotions of others. Somebody is crying. I'm listening to them talk. How am I supposed to feel? Well, I'm trying to connect with their emotions. That's default. And not surprisingly, this is related to moral reasoning, right? It just occurred to me, I guess my mind just wandered, that in people who are considered to be psychotic, something makes a moral or just sense in their brain. However, they have a reduced ability to be empathetic. So a psychotic person would be like a vigilante who thinks it's okay to go out and just kill a person because they think that is just, right? Yeah, so it'd be interesting, or like Hitler or something like that. That's the classic case. Is there some sort of reduced connectivity in this person's default mode network where they're dissociating these two traits of the wider distributed social evaluations. So is it okay for men to wear short shorts and show their thighs or not? Is that socially uncool? Social categories, reflecting on social characteristics and status of a group. So this is all peer stuff, all right? A lot of interpersonal stuff. And then last, a default mode network gets invoked when you're thinking about the past or the future, reflecting upon what's happened or projecting into the future. So, what did you do for Thanksgiving last year? What's going to happen in 3 days from now when Aunt Selma comes back and burns another turkey? Episodic memory. So you have this like graven image in your brain of when Aunt Selma decided that it was going to be a good idea to cook the turkey at 550 for 5 hours, and then the fire department came, and the look on Uncle Herman's face when he opens the door and smoke is billowing out. Yeah. And he thought it was Johnny smoking a cigar somewhere. So anyways, story comprehension. Being able to string all those different events, those memories into a storyline, into a narrative. So that's default mode network. Yep. Yep. I don't know.
Eidetic memory?
What?
Photographic?
Yes.
So I don't know. I'm going to admit my ignorance. I don't know actually how, because that is not something that everybody has. And so I don't know how that relates to the default mode network in terms of, but episodic memory is, so, there's a beautiful story. Let's do it this way. There's a beautiful story by a guy named Borges, who is an Argentinian author. If you've never read him, you should. And he writes this one story about a guy who never forgets anything. He never forgets anything. And he's walking around Buenos Aires, and he remembers every detail of Buenos Aires. And it drives him insane because the town has changed over the course of his life. And he cannot expunge the memories of every breath he's taken, right? And so that's not our brain. People think that our brains are these amazing sponges that suck up everything around them. And that's not actually the truth. Our brains are there to filter stuff out. Our brains are there to actually delete information and just pick out the little bits that are important. I would say that maybe this fictitious memory that I have about Aunt Selma and Uncle Herman from last year, I can recall it in vivid detail because the turkey caught on fire and there was a fire guy with a hose shooting at the oven, but I don't really remember the day before or the day after at all. But this one episode that was significant got burned in my memory, and the default mode network is there to like recall those details. Yes.
One thing we talked about your graduation. There you go.
Yeah.
Yeah, but even then, when you remember that's just how vividly you remember it. It's the time when you think
It's harder to.
it's not like that's instead like you recall yourself from memory may or may not happen.
Sure, absolutely. Yeah. This part of the brain is going to be involved in that, right? Nobody's saying that that a memory is a faithful recording of the past. I don't think that that's what this means. It just means that when you remember some kind of episode that happened, that it's the default mode network that's responsible for reproducing that experience in whatever way it happened in the brain. Does that make sense? Okay. All right. So we've been talking about default mode network, but there's another function to the brain, right? There's all this time when we are in the moment, when we are on task, when we're focused on something. And we call this the attention network. The attention network. So here's this model of the brain. It has our prefrontal cortex. It has some of the cingulate in it. And here's the attention network. Totally different but adjacent parts of the brain. And this data came out of this paper here. It's maybe a little bit hard to see, but it might be better if they were zoomed in a little bit on the line. Here are these brain leads. So this is some EEG. And we're seeing, when we see a spike in this attention network in the moment, we're seeing a dip, a valley in the default mode network and vice versa. So they are anti-correlated, right? When the default network is happening, attention network is not. So let's look at this. Here is this zoom in. So the orange and yellow and red, the hot colors are default mode. The cool colors are the attention network. And they are truly anti-correlated. This is from the Franson paper that I pulled out. So what kinds of attention are going to light up this other distributed network in the brain? All kinds of attention. So target detection. So I'm focusing on this mandala quilt over here. Or I'm listening to a sound. I want to hear the sound of the radio. That's a form of target detection. Reorienting. I'm sitting here talking to this side of the class, and I don't want to ignore this side of the class, but maybe I do. I apologize. And you catch my attention by raising your hand. And so I have to reorient my attention somewhere else. It requires this attention center. Any kind of decision making. And think about how many decisions you make in a day. How many decisions? I am going to decide to pick up my phone right now. I have to. So many. Like an unbelievable number of decisions. This is this part of the brain. That's helping you do that. Like you decided to say something, right? That somehow, even for a moment, involved that part of the brain to get the tongue moving and form the words that you want to say, etc. Classification. So I'm thirsty, right? And so I need to pick something up to drink it. And I'm going to look at the table here. These are the things I can pick up. I could pick up my hat and drink it. I could pick up the case and drink it. I could pick up this cup and drink it, or my phone and drink my phone. So I need to categorize them and to classify them into things that I can drink and things I can't drink. All right, and so that's part of the attention network. And then selection. I'm going to select this thing that I've classified and take a sip from it. All right. We call this the task positive or attention network, the part of the brain that gets stuff done, focuses, the part of our brain that is here now, so to speak. All right, let's see. So here's a picture of it. I guess I could have done a better job labeling it, but I'm just blowing it up so we can see it. A little bit different parts of the brain. Rather than on the medial side, we're on the lateral aspect. And not surprisingly, we've got the insula involved. We talked about the insula before a lot, didn't we? And what did we say about the insula? What does the insula do? It's responsible for our conscious. That's the thalamus. But the insula is kind of like glommed right on top of the thalamus. It's responsible for our consciousness, so our awareness. If you have a lesion, a stroke or something, or a tumor in the insula, it's bad news for your sense of view. Insula, also some anterior cingulate cortex. The cingulate posterior part is what we said was part of the default mode network. Anterior is part of attention network. The dorsolateral prefrontal cortex, so on the sort of back and lateral side of the forebrain. the lateral inferior parietal cortex. These are some regions that are part of this large-scale distributed attention network. All right, so let's compare them and think about them. And this is showing the anti-correlations, the regions of the brain that light up in one instance versus the other. First, there's the attention network. I'm engaged in a task. I'm focused on a target, right? And I'm meant to click a T, and there's the T. I'm going to move the cursor and click it. The blue regions of the brain will light up. Whereas in the default mode network, I'm not told to do anything. They just are showing these pictures on the screen, and I'm just doing whatever I want, and I'm thinking about having dinner with my partner or whatever. Mind is wandering. And when that happens, other parts of the brain are lighting up, this default mode network. So let's see if we can begin to tease out the actual, like what's happening in the brain when we're meditating, and then correlate that with actual lived experience. This is what I would like to happen in lab on Thursday, next Thursday. That's what I'm hoping to, a week from Thanksgiving. So this was the idea, is that we'll have some sort of EEG that will be a trace or like an objective sense of what's happening in the brain. And I want to see if we can correlate it with our subjective experience. Right? Well, let's see what the data in the literature says about that. So here's the paradigm. When you're meditating, your mind may wander. It certainly happens. Your mind may wander. You become aware of that. So this is like sort of breaking down what's happening in the brain. This is our subjective experience. What is happening when we're meditating? I'm aware of my mind wandering. I become aware of my mind wandering, and I try to refocus. I shift my attention, and I become focused again. All right? And I remain focused until my mind begins to wander. This is the cycle that happens. My mind can wander. Oh, my mind's wandering. Well, let's see if I can bring it back in. It's the shifting attention, and I achieve that, and I get to focus. So we have these 4 different events that are happening. Mind wandering, awareness of mind wandering, shift our attention back to the focus, and then we're deep in the focus. All right? Is it possible to query these activities objectively, like quantify them? Well, the answer is yes. There is this group out of Atlanta at Emory that was published about 6 years ago that looked at this. And so what they did was they took 14 breath-focused meditators. They were just going to focus on their breath. Their breath was the point of focus for them. Throughout the age range, mostly female, a few males. And they stuck them in one of these functional MRIs. It's a big MRI tube that looks at blood flow in a brain region when that part of the brain it's correlated with functioning in that brain, right? Stuck them in the big tube, in the big magnet, and they were meant to focus on their breath. Whenever you realize, when you're sitting in there focused on your breath, whenever you realize that your attention has wandered, you click a button. There's a little button that you click. That's all you have to do. You're sitting there meditating, mind has wandered, click. That's it. And so this press button data is their subjective report on what happens. Certainly whatever happens on Thursday, for better or worse, assuming that I can figure out how to get the EEG to work the software the way I want it to, that's going to be much more crude than this, even as limited as this might be. But we'll see what happens. So here's the way they mapped the functional MRI data onto the timeline. So there was the click, right? Here's the brain scan, and there's the click. They're assuming that click is somewhere in that each of these cognitive tasks. So being mind wandering, aware, shifting, and focus. That being aware and shifting their focus, shifting their attention back to focus, these each have roughly 3 seconds, right? So across the brain scans, they were going to take a 3-second window around the button click, call that awareness, say before that is mind wandering, and they're only going to take 3 seconds of that, and the rest of it delete. And then shifting, they're going to look at the next 3 seconds and call that shift as the attention shifts back. And then take the next 3 seconds and call that focus. All right? And then whatever happens after that, they're not even interested in it. It doesn't matter. So just the 3 seconds, 3-second blocks right around that event of going from being mind wandering into focusing. All right? And their hypothesis is that default mode network is going to be predominant when your mind is wandering, and various attention networks are going to be engaged during these other moments, during awareness, shifting of attention, and then sustained focus. So let's go through them. The first one let's look at is when they actually click the button. Turns out when the person is clicking the button, when they become aware, conscious of what's happening in the brain, that their mind is wandering, they become aware of that fact, self-aware. Well, not too surprising, bilateral anterior insula lights up. All here, is all in the insula, and then a little bit here along the midline, the parietal lobe. All right. So this is what they call the salience network, and it's responsible for helping to identify things that are relevant to what's happening to you. You're trying to piece together what's happening, and you want to find aspects that are relevant to that, right? So, for example, maybe my pants are itchy, and I'm aware of the fact that my knees are itchy, and okay, do I pay attention to the fact that my pants are scratchy, or do I pay attention to the fact that my phone is blue? Well, I don't want to pay attention to that. I want to pay attention to the fact that my pants are scratchy. So that's another function of this awareness or salience network. Okay, so this next little 3-second block, they found across all of these meditators that there was a consistent pattern of functioning in this other brain region. They called it part of what's called the executive network, and it's an attention. It's part of this suite of attention network brain regions. So it's simply going to respond to some sort of stimulus by grabbing the attention of your brain and controlling that attention. The frontal parietal attention networks. All right. So I said earlier in the lecture that the prefrontal cortex is this part of the brain that exercises control and judgment over the emotions and the activities of the brain. And part of that is lighting up here, right? So it's responding to whatever stimulus is coming in, and it's controlling the attention, exerting a little bit of, maturity. And then a nearby neighboring part of the brain, also called the executive network, was lighting up during the actual sustained focus of meditation, the dorsolateral prefrontal cortex. Whoa, look at that. Yeah. Yeah. The goal of this part of the brain is to keep the goal in mind. If you're all right with the circular sentence put together. So working memory, keeping the goal in mind. What is your focus? Right? Focus on the breath. Keeping the focus on the breath. And then lastly, mind wandering. So medial prefrontal cortex, posterior cingulate, parahippocampus. These are all the regions that we already talked about in the default mode network. So more or less confirming their hypothesis, all right? More or less confirming their hypothesis is the take home. So let's put it all together. That was all the data, and maybe that was painful. But we can put it all together in sort of a pattern of motion in the brain. Let's begin with focus. When you're focused on something, we have dorsolateral prefrontal cortex, aspects of the attention network, this executive network as part of the broader attention. Then the mind begins to wander, and we have the default mode network comes in to play here. And these are in the regions that we talked about earlier, posterior cingulate, the prefrontal cortex. We become aware that our brain is wandering. This is the salience network, and involves the cingulate cortex and some insula. And then lastly, this shift, again, to an executive network. So you can see this pattern of brain activity that's moving around the brain during meditation. And what's the significance of this? So we have correlated, what they've done here is correlated discrete neuroanatomical regions in the brain, functional regions in the brain that are now correlated with subjective experience. So when you feel that your mind is wandering, or that you feel that you become aware of that, and you wrestle control back to your focus, or when you feel focused, these are genuinely neuroanatomically distinct regions of the brain, and they've been able to identify that and can show the patterning that happens in the brain. All right, so this is what we're doing here is just trying to decode the pattern of brain activity during a meditative experience. All right, and it turns out that the more experience you have with meditation, that making that shift, becoming aware that your mind is wandering, and then making the shift to focus, it becomes easier. It shouldn't be a surprise. It becomes easier with time. So here is, the blue is low practice, so us, versus a high practice, someone perhaps like Sarah, or more than her. And what are we looking at? So we're looking at seconds from the beginning of the shift condition to the signal change from the baseline. So people who are high practice meditators, they're able to bring to end this shift period much more rapidly than a person who is low practice. It's not as sticky, if you want to think of it that way. So that processing, we've all been there, like, oh my God, I hear all the people outside, the clock is 45 seconds past the time at the end of class, it is hard to keep my brain on task here. I'm trying to focus on the end of lecture. The more you do it, the better you are able to do it, and the less time you get caught in that painful process of wrestling your attention back. Okay, Any questions on that?